Hey, so in this video, I'm going to talk about kinematics. So yeah, this is for AP Physics 1. So here we go. Okay, so the first question is asking which object is farthest from the origin at time 2 seconds. We can check over here. We have this. Oh, oops. No, this one. Okay. So we have this and we have this, and we can see that they are both at 1. So in physics, -1 and 1 are the same distance. It's not like math where 1 is greater than -1. No, they're the same distance. So the answer for this one would be D. They are the same distance from the origin, but in opposite directions. Question 2. Which object moves with a constant non-zero acceleration? So on this one, we have this one and this one. So a constant non-zero acceleration, we can see that because, or wait, let me make more room. Okay, we can see that because the graph is going up like that, it means that it's accelerating. And this is for object B. On the other hand, object A it has a constant acceleration. So this means that it's like not accelerating. You can see that it's a straight line. So on this one, at 2 seconds, it would be object B. Which object that you start right over here in the origin. For this one, we can see that object A comes to a stop or ends right at the origin where it's supposed to be. So we can put that, we can put that it's A. Now on this one, let's see. The graph above, let me highlight that, let me erase all this, okay. The graph above shows the velocity versus time graph of an object moving in a straight line. At what time does the object get past through its initial position? So we look. Starts, it goes down and then it goes up, and it crosses initial position again. So the answer would be A, because at 1 second it crosses the initial position where it started. Okay, moving on. A body moving in the positive x direction passes the origin at time 0. Between 0 and 1 seconds, the body has a constant speed of 24 meters per second. At time 1 second, the body is given a constant acceleration of 6 meters per second squared in the negative direction. The position of the x of the body at time 11 is... So on this one, so on this one, number 5, we know that we could say our initial velocity is 24 meters per second. So initial velocity would be equal to 24 meters per second. And then the time interval, is 1 second. And the acceleration would be 0 because, oh my god, sorry, because, okay, sorry about that. I came back, my brother came into my room asking for something. Okay, so where were we? Okay, so the acceleration is 0 because it is at constant velocity. So, moving on, since we can use the displacement equations, the kinematic displacement equations, and we know that the equation would be delta x1 is equal to v0 times delta t1, and then we can plug in what you know. So delta x1 would be equal to 24 meters per second times 1 second, and meters per second times second. These cancel out and we're left with meters only, and we know that it is equal to 24 meters. Okay, so now at 1 second, so t1, or t is equal to 1, we know that, or actually no, wait, the velocity, the velocity is 24, the position is 24 meters, so x is equal to 24 meters, and it's x because on a graph y is up and down, then x is side to side. Okay, now we can find the time interval or the acceleration by doing or plugging what we have into t final minus t initial, which is equal to 11 seconds minus 1 second, which will equal to 10 seconds. Okay, so our acceleration is our acceleration is -6 meters per second squared. Now we use a displacement equation for the constant acceleration. So we have delta x2 is equal to v1 times delta times 2 plus 1/2 a delta t squared. Okay, so now we're going to use this equation. Let me erase this. I need more room. Okay, so we have that delta x2 is equal to 24 meters per second, 10 seconds, and then plus 1/2, -6 meters per second squared, and then 10 seconds squared. Okay, and then when we do these, it's going to be 240 meters plus 1/2, -6 meters per second squared, 100 seconds squared. Okay, and then we're going to substitute. So the AP Physics one is algebra based. Just letting you guys know. I should have mentioned that in the beginning. So 240 meters minus 300 meters is -60. So delta x is -60. Okay. And now the final position, we know that it is time is 11 seconds. So x final is equal to x plus delta x total, and then this is just, which is equal to delta x1 plus delta x2. So x final is equal to 24 meters plus -60, and we get the final question or answer to x final is equal to -36 meters. And would you look at that? C is -36 meters. Now question 6. A driver initially moving horizontally with a speed of speed of v, dives off the edge of a vertical cliff and lands in the water. A distance d. How far of the base of the cliff would the driver have landed if the driver initially had been moving horizontally with a speed of 2? Okay, on this one, so the motion in the horizontal x and vertical y directions are independent. So vertical motion, so in the y direction, sorry, that's notification. So vertical motion in the y direction, the time it takes for the driver to fall is determined only by the cliff height, h, and gravity, g. So the height would be equal to 1/2 g squared, which would then be t is equal to grad 2h g. Okay, since the height of the cliff is constant, the time of the flight is the same regardless of the initial horizontal speed. So since the height oh my god, bro, height of, oh my god, sorry about that. The height of the cliff is constant. The time of flight t is the same regardless of the initial horizontal velocity. So the horizontal motion in the x direction, there is no acceleration, so 0, so the horizontal distance r is given by r is equal to x times t. Okay, so the initial speed is v x which is equal to v, and then the horizontal distances are 1, which is equal to d, the distance. The initial speed to v would be px equal to v, because it is asking what if it had been moving horizontally with a speed of 2v. That's where the 2v comes from. And because it's 2, we're going to do the horizontal is r2. Now we set up the equation for the new distance. So we plug in what we have. So plug in what we have. So we have that r2 is equal to 2v times t. Now substitute the expression from the first one into the second one. So we substitute that in, which is r2, which is equal to 2 times v t r squared is equal to 2d, and then the answer would be 2d. So here it is. A ball is thrown and follows the parabolic path shown above. Air friction is negligible. So in AP Physics 1, for air resistance or air friction will be negligible. So point Q is the highest point on the path. Points P and R are the same height above the ground. Okay, and now this one is asking question number 8. How do the speeds of the ball at 3 points compare? Well, we can see that it says point R are the same height, but okay. Something you guys have to know. Point P and point R are the same speed because are at the same height. And then Q, what you have to know is that whenever you throw something up in the air, so person, he threw a ball, and then maximum height, the ball stops. Like, you don't see it, but the ball stops in the air and then it comes down. So at that time, the ball stops and then it comes down. Then it comes back down. So knowing that, we have that, let's see, VP is, no, so it's not that one. VP is equal to VR. So it would be D. Pretty easy. Which of the following diagrams best shows the direction of the acceleration of the ball at point P? Okay. Point P. So we have this one. Okay, so on number 9, question number 9, we know that up here P is moving up, but gravity is still acting on it, and because of that, acceleration would be decreasing slash pointing down. So it would be B. D, not B, D. Okay, the graph above represents positions x versus time for an object being acted on by a constant force. The average speed during the initial interval between 1 and 2 is most nearly... Okay, on this one, I'm going to let you guys practice this one, and I'm going to pause the video right here, and then I'll come back with the answers and all the steps on solving it. You guys try it out. Okay, so in order to find this, we have to calculate the average speed as the total distance traveled divided by the time elapsed. So, average speed is equal to total distance over time elapsed. Okay. The interval is from 1 second to 2 seconds. So, since the position x is always increasing, you can see that it's literally increasing. The total distance is equal to the displacement, so x2 is minus x1. So, at time 1, so position at 1 second, reading the graph, the position at time 1 is exactly x1, so we have that distance is equal, distance is equal to 12 meters minus 6 meters, which would just be equal to 6 meters again, and then using plug it in, we have average speed, which is equal to 6 meters over 1 meter, which is just equal to 6 meters, or not 1 meter, seconds, 1 second, 6 meters per second, and T is that. Okay, last one that we're gonna do is this page. Okay, at time 0, car X traveling with speed VO passes car Y, so right there, which is just starting to move. Both cars both cars then travel on 2 parallel lanes of the same straight road. The graph of speed v versus time for both cars are shown above. So, okay, so on this one would be A. Okay, on number and then now we're gonna do number 12 from time 0 on time 40 seconds. The area under both curves are equal. Therefore, which of the following is true about T40? We know that it's B because car Y is passing car X. Okay. Oops. Oh. Okay. Which of the following pairs of graphs shows the distance traveled versus time and speed versus time for an object uniformly accelerated from rest. Okay. Let's see what we have. Okay, so we have highlight, always highlight. I should have done that. We have the following pairs of graphs shows the distance traveled versus the time graph of an object uniformly accelerated from rest. Speed is increasing, and it's curving. The distance is curving because it is going further. On this one, speed cannot be curved. Like, speed cannot be curved. So we know that these are not it. Now we're left with A and B. So, or A and D, not B. B. So, G has a downward curve, and then the speed graph is upward. So, and then A is an upward curve, and straight, which is a straight line through the origin. So we know that A is the correct answer.